Hey guys, how's it going? Welcome back to the channel. So today we're gonna be going through something like 7 questions. We're gonna solve them with Pandas, Python. Um, I previously solved 7 questions with SQL, so I thought it would be a good idea to kind of like solve these with Pandas also. So these are more like data engineering, data science type of questions. I'll say if you're more interested in like lead code, software engineering question, check out my YouTube channel also. You'll see that I've done some lead code questions. So also guys, I would like your input. I've been doing them in bulk, like 7, 4, 10 or something like that. So I'll really appreciate your input if you like this way, or you just want me to do them one by one, something like that. Anyway, the first question is largest Olympics. So we're told that we need to find the Olympics with the highest number of athletes. So the Olympic game is a combination of the year and the season and is found in the games column. So output the Olympics along with the corresponding number of athletes. So essentially what they're saying is that like for each Olympic, you just need to find the Olympic that had the highest number of athletes. For instance, an Olympic is determined by year and the season. So we don't have to group by year and the season because we're given a column called game. So we can use that to group by that. Then what we can do is that we can then um, uh, count the number of athletes for that game. So what I'm saying here is that we can think of like if we look at this schema here, we have an ID which correspond to an athlete. So we can see the athlete name, we can see their sex, gender, and we can see the Olympic that they participated in. So what we need to do is that for each Olympic, for each game, we need to then count the number of athletes in that and give their results the highest at Olympic with the one with the highest number of athletes. I think if I start coding here, actually, it will start to make sense in more detail. So, without wasting any time, what I'll do is that I'll then group by games. So I feel like we don't have to group by the year and the season because we're told that this is found in the column games. So you can think of like they made our life easier. But if it wasn't the case, because an Olympic is a year and season, we will have grouped by this. But in this case, they have actually done it. So we're gonna group by that, and I'm just gonna to preserve my columns. I'm gonna say index as index equals to false. Okay. Then I just want to transform the ID column mainly because I want to count like for each Olympic. I want to count this. So what I'm gonna do is that I'm gonna use this function and unique. The reason I'm using this function is because we could have duplicates of athletes. So it's an edge case whereby, let's say for each Olympic, you have duplicates of people. Then this essentially what it will do is that it will then make your results to be incorrect. So what I'm doing by n unique is just I'm making sure that the IDs that I'm selecting, they're all unique, meaning that I'm selecting all the unique athletes. Okay, so when I'm done with that, the only thing that I need to do is that I need to sort the values because we're told that we need the highest number of athletes. So I need to sort them to get the first one. So I'm gonna say dot values, and I'm gonna say by equals to ID, and I'm gonna make sure that ascending equals to false. And this is gonna give me all the values as sorted. So what I need to do is that I need to then select the head, which is going to be 1. think I made a typo on ascending. Sorry about that. Ascending. And this is what we have. So I'm going to submit, and it works. So the key takeaway, guys, here is that we just needed to group by, just to make sure that as usual, let me just take it to some sort of like to explain this. So let's say we have a table like so, and you can think like we have game 1. So this is Olympic 1, right? This is game 2, maybe Olympic 2. You know, these are years. You can think of like years and season, right? So game 4, something like that, right? And for each game, you have like number of athletes, right? Like you have like ID1, ID2, ID3, something like that, right? 2, 3, something like that. So what we just did was that we said for each game, we just want to count how many IDs are there. So there's 1, there's 2, there's 3. Then we say, okay, for game 1 equals to 3. Then let's go to game 2 now. So maybe there's like 7 IDs here, right? 7. So I'm just gonna say game 2 equals to 7. And maybe same thing, game this, we have 1 ID. Then we just say game 3, we have 1 ID. Then what we did was to sort this, right? We sorted them, and we said ascending is equal to false. That means it's going to be descending. So it's going to be 7, 3, and 1, right? So this means that this game here, game 2, is number 1. Then we selected the first row and we took the 7. We submitted our result. Essentially, that's what we did. Just to visualize it, right? So I just want to solve this also in SQL. Basically, I'm just gonna copy the code that I've already written because we have a few questions to go through. So I'm just gonna copy it here. Okay. So from an SQL, what we did was that we select the game and we say distinct ID, and we count the athletes. Then we still group by this game. Then we also order by the athletes, right? So that we get the top we get the top Olympic with like the first athletes. Then we limit the results by 1, and this is gonna produce the same results. So I'll share the code with you guys when I'm done with all of this. So yeah, anyway, let's look at the second question now. So coming to question number 2, we're gonna look at premium versus freemium. So we're told that this is, by the way, this is a Microsoft and a hard question. So just keep that in mind. So we're told that we need to find the total number of downloads for paying and unpaying user by date. And we need to include only records where non-paying customers have more downloads than paying customers, right? The output should be sorted by earliest date. First, we contain 3-column date, non-paying user, and paying downloads, non-paying downloads, and paying downloads. Okay. So as usually now, guys, I like to break these problems into like solvable problems. So what I'll do is that I'll first like look at the first statement, like find the total number of downloads for paying and non-paying users by date. And I'll ask myself, do we have a table for paying and non-paying users? So let's look at the schema. So if we look at the schema, we can see that we have a user dimension, we have account dimension, and we have download dimension. So we definitely have a user and we have account, which actually tells us if the user is paying or not paying. Okay, so because like I said, I like to break these problems into sub problems. So what I like to do is that I like to join the user table with account table so that I can be able to get so that I can be able to know if that user is paying or not paying, right? And then I'll somewhat separate the tables by non and paying users, by non-paying users and paying users. Okay, so the reason I'm doing it this way is because I can be able to solve a problem like as a subset problem. Then when I'm done, I join these two tables. Then this way I don't have to deal with one junk problem at the time. So separating these tables for me always works because I can be able to focus on each problem at the time. For example, now it's easy to solve something like if I ask you find the total number of downloads for paying users, you can know that okay, what I will do is that I'm just gonna take the user table and join it with the account and filter by paying users equals 2 years. Okay, and you do the same thing for non-paying. So what you do after that, you just go to the next statement. It says include only records where non-paying customers have more downloads than paying customers. Then you solve that just like that, right? So that's my point in solving these problems. So I'll visualize it when we're deeply involved in it. So what I'd like to do is that I would like to kind of have a graph skeleton of how we can go about this. So what I'll do is that I'll say user accounts equals to, so like I said, I'm just gonna take the user dimension and I'm just gonna try by all means to match it with the account dimension, and I'm just gonna say match this, but make sure that you match this on the account ID. So this is like what we have. So we have account ID, so we assume that this account ID for the user is associated with the user here, so hence we join it by that. So we're just gonna say account ID, and I'm gonna say equals to, I'm just gonna do an inner join mainly because if a user does not have, or maybe this account is not found inside here, then obviously we don't have to do this. We don't have to do this, solve this problem for that user. We don't have to include them in our solution. Similarly, if there's an account without a user, then it doesn't make sense for us to include it. So inner join is a safe way to go. Okay, so now this is how our table looks like. I'm going to show you the table because I feel like this is more like a complex problem, so I want you to see all the intermediate stuff. So this is what we have. We can see that from this equation we have joined the two. So we have a user ID, we have account, and we have a paying customer. So this tells us if this is a paying or not paying. So what I would like to do in this case is that I would like to, because we want to compare paying and non-paying customer, so let me show you this. If you compare them like this, you see like this. Let me show you something, because the reason I want to separate them, this is actually a good reason, is that we have them like this. We have like paying customer yes, paying customer no, paying customer yes, paying customer no, right? And maybe we're gonna join another table which is downloads. Maybe this one has 4 downloads, 3 downloads, 2 downloads, 1 download, right? So separating them, it makes sense because now the question says we want to compare paying customers and non-paying customers by downloads. So it becomes hard to compare them if they are like this, right? You see how they are on the same column, right? But the point here that I'm raising is that you want them to be like this. You want paying customer to be here, like paying and non-paying. So you want to separate these two into 2 columns, like non-paying, right? So what you do is that you then have paying customer, like then you have their downloads, maybe 4, maybe here 3. Then this way you can compare them. You can write an SQL script to Pandas code or whatever to compare them like this horizontally. When they are vertically, it can be hard on a column wise. So you want them to be on a row wise shape. So that's my point. Okay, so hence now my next step is that I want to then separate these two. So I'm just going to say paying accounts equals to user account. Then with pandas, how we filter is that we say user account. I'm just going to say accounts. Then we take that column, we say paying customer, right? Then I'm just going to say I just want where equals to yes, right? And I'm just going to copy this, guys, just to save our time. Then here I'm just going to call this as non-paying customers, and I'm just going to say this is yes, no, sorry. So if we take an example, I'm expecting to see this table with no's only, meaning that these are all non-paying customers. Okay, so if we take a look at this, what did you do? Oh, sorry about this. Unknown syntax, line number 9. Did we miss something? So I'm just gonna do this. Might have made a mistake. Okay, I'm just gonna paste. So we have paying customer. Did I miss something? So paying this, then we filter by that, then we say equals to yes. Oh, I can't see anything. Wow. So, okay. Yes, then I'm assigning this. So, and let's see if it was complaining because I didn't, there was a space there. Maybe. I don't know. Paying customer equals to yes. Let's run this. Okay, it works. It could have been that I had a space somewhere. But anyway, so this is gonna be non-paying customers, and what you wanna do is that you wanna say this is no. So like I was saying that for an example, this will look like it will have a table, still the same table, but it will have all the no's to show that these are all non-paying customers. But we don't care about these nodes, right? The only thing that we care about is the download. Don't forget that we say that find the total number of downloads for paying and non-paying user by date. So they say by date. So what you want to do is that you want to say, okay, I want to get the downloads for non-users, right? I want to get their downloads. So what I will do is that I'm going to say paying, non-paying users downloads. That's what I'm going to do, right? I'm going to say non-paying users. I just want to match you with the table that we have that have been given to us, which is called downloads facts. Okay, and what we want to do from here is that we want to then order this. What is the similar column that the similar column is called the user ID. So we're gonna join these by user ID. And how are we gonna join them? We wanna join them by inner join because it makes sense. We only want the users with downloads, so it's safe to use an inner join, right? But we need to be extra careful. If you get this table, it's possible that you wanna make sure that you get these by downloads. Remember that if you don't get them, not by download, sorry guys, I meant by date. You see here they say by date. So what you want to do in this case is that users could have downloaded multiple, they could have downloaded multiple songs. I don't know what it is, but on the same day. So when you go into join, this is going to create duplicates, right? So when you join, you want to make sure that your join has unique IDs on both sides. So in this case, what you want to do is that you want to make sure that you group by date. So okay, so why are we grouping by date? Because we're told that we want this by date, so that's why we chose the date. So but the point here, okay, let's go to whiteboard. I think maybe this might be quite difficult to understand, but the point that I'm raising, guys, is that if we scroll down, if like we have two tables, you have two tables, and this table here, it has some sort of like ID, right? It has ID 7, ID 7, ID 7, and this side you have, maybe you also have ID 7, ID 7, something like this. So what you have like number of downloads for that day. Maybe the day is the same, but you have like 2, 3, 4. So when you're going to join these two, right? When you're going to join these two, because of these IDs are repeated multiple times, you're gonna end up like having duplicates like of sevens. So what is the join will try to match this 7, match it with this, 7 this, so it will try to have this, and you don't want that. So what you want to do is that you want to maintain 1 7 for each day. So and you can tell like also the day is gonna be corrupted, so you want to maintain the date, the single one. So okay, so hence here we grouping by date. Okay, so what we do is that we group by that, and we just want to make sure that we don't lose our columns, so we preserve them. So I'm just going to paste sum. So this is going to make sure that it's the download. And for me, without wasting any time, I'm just going to copy this and paying users, and let's look at an example, guys, what I mean. So did I miss something? I think I did, right? So I think you need to have some sort of like a backslash here, especially if we're gonna use, it says line 16. Let's see. Okay, let's do this so that we can look closely at the program. Okay, I think I forgot to close this. This is fine. Dot group by date is on that there's a comma. Yeah, I think it's fine. They say unexpected character for line continuation character. Okay, I'm just gonna remove this. So this is more like like coding on a on a Word document. It sounds like man, I'm telling you, this thing is so hard. So you can't even see anything. That's why I have to remove all the code. It's like it's so hard. It's because it's like you're looking for that bug, but you can't get it. So you know what? Let's see now if it works. Okay, it works. I don't know. I wrote the same code, but I don't know what the problem was. Guys, this thing. Anyway, let's see. You know what? I don't know what the problem was there. This thing is so hard. Okay, it works. But anyway, guys, sorry about that. So what I'm saying now is that you can see that we have the paying users, and we managed to get the download for those users. So if we scroll down, we can certainly see that, okay, for these paying users, we can see their number of downloads. And the good thing is that we have done this by the date. So this user for this day, this is the number of downloads that they've done. So for this day, this is the number of downloads that we've done. So we're gonna join by date, because they want us to compare these things by date. So hence we needed to make sure that the date are unique, like I explained in the whiteboard. If you don't have a unique ID that you're gonna join by, you're gonna end up with duplicates. Your results are not gonna be accurate. So you wanna make sure that everything is just as unique. So hence here we need to group by to enforce that uniqueness for the dates. Okay. So now we have this. What we can do is that we can then say meshed users. Okay. We can take the paying downloads, and I'm gonna actually say I'm gonna do that so that I keep it simple. Match, and I'm gonna take in the non-paying users. Join these. I'll let to join them on date. That's what matters. Okay. How? So just gonna keep everything. I'm gonna do an alter join. So on is gonna be equals to date. So we're joining by date because we're told that find the total number of downloads, paying and paying user by date. So we don't necessarily have to do it for the users or something like that. We just care about the date. Hence we need to make sure that the date is unique, and we use this group by here to make sure that if that was not the case, we're gonna have duplicates. So, but also going back on the technique that I told you guys about, which was that we need these things to be on the same row. So let me look at now what the problem is. Did we miss something? Just gonna okay, cool. So what I was telling you about when we started is that now everything is on the same row. Can you see this? So we can see that, okay, for the non-paying users, and these are paying users, we can compare them. They're on the same row, and we can compare them by the date because we joined by the date. So we know that on this day, this is the number of downloads that these non-paying users they made, and our life is easier. So what we can do, because now our life is easier, we can say final results, okay, is going to be equals to meshed users. Okay, then we take meshed users, we take the downloads. I know by X, it denotes, I think, non-paying users. Downloads X. I think actually this is a nice feature. So usually with SQL, like we'll have like the same column names, and now this way it helps us so that we don't have to rename. So I actually like this feature. So users, then I'm just gonna say downloads. So what I'm saying is that I want to keep the downloads. Actually, before we go there, I want to make sure of something, because we're saying that meshed, but what does X denote, guys? Is it non-paying? It's paying users, right? X is going to be the first one here. Then I think it's paying. And the question says, find the total number of downloads for paying. So which means that we want to say paying greater than non-paying. Okay? So I hope X is paying. So okay, cool. So what we do is that we just want all the greater days for that, right? So that's what we're gonna do. So then I think actually it's better if I show you the results so that we work our way through the solution. So now we have all the rows whereby the downloads were greater than the non-paying users, right? But we're told that here, okay, what are they saying? They're saying that the output should be sorted by the earliest date first, and so let's do that, right? So I'm gonna say pass this thing here, backslash, and I'm gonna say dot. So I want to sort these values, right, by date. That's what they said. By equals to, it's gonna be date. They said alias, so it's gonna be ascending equals to true. Ascending, I always get the spelling wrong. Ascending equals to true. So do we have the right results as of yet? Yes, we do. So the final thing is that we're told that okay, 3 columns, date, non paying, then that's it. So we're just gonna say date. We're gonna say downloads, then downloads X. Then we're just gonna say downloads Y. Okay. No. What did you do, guys? I think it's because of this, right? Is it because of this? Because I don't know what this X meant. I think it's because of why X will be this. Because okay, it worked. Yes. So yeah, I think sorry about that, guys. I think why, and I told you that I was actually skeptical about changing them because why it refers to this. The thing is, we did not rename these columns, so yeah, but we just needed to know which one was Y and which one was X. Anyway, it worked. This was quite, I like this question, guys. Mainly the key takeaway is that it kind of like stretches you, especially it also improves your panda skills. But most importantly, the technique, for me, I like it. Maybe there's a lot of ways people have solved this, but for me, how I kind of like went about it was that I just decided to separate the non-paying and paying users. So usually when I want to do some sort of like comparison, let's say they want to say something like greater than, smaller than, but then when they ask me these type of questions and I find myself actually I don't have those columns like horizontal, they are vertical, then that's when I know that I need to kind of like create two tables so that I can actually be able to compare them. When they're horizontal, they're easy to compare. Vertical, it's hard. So that's why we needed to separate them. Then, yeah, I think that's the solution. Let's go to the next one, and yeah. And now we're looking at question number 3. So, it's by Facebook. We are told that Facebook has developed a new programming language called Hack. To measure the popularity of Hack, they ran a survey with their employees. The survey included data on previous programming familiarity as well as the number of years of experience, age, gender, and most importantly, certification with Hack. Due to error, location data was not collected, but your supervisor demanded a report showing average popularity of Hack by office location. Likely the user ID of employees completing the survey may start. Based on the above, find the average popularity of Hack per office and output the location along with the average. So the key, they wrote a lot of paragraph, but the key here, I'll say, guys, is just you need to find the average popularity of this programming language, and we need to find it by the location, meaning that there's San Francisco office, what's the popularity? Then another place, what's the popularity? Something like that, right? Like it's their office or like those. So looking at the schema here, we have 2 columns, which is the employees who took the survey. Okay, these are the Facebook employees. Not all of them took the survey. That's the first important thing that I should note, so that it might actually impact your join. Then this is the Facebook has Hack survey. So yeah, how would we then go about this? I think this is an easy question, quite straightforward. The edge case, I'll say, just be careful on your join because we only want the employees that took the survey. So I'll say it's it would make sense for us to actually do a left join. So we take the Facebook employees, then we left join on the what's this? The Facebook hack survey table. We do an inner join, not a left join. Sorry about that. We do an inner join because an inner join is just going to make sure that we don't get all the Facebook employees. We just make sure that we get the employees that took the survey, and employees who left. I don't know if we should count them, but inner join will do the trick. If an employee is not in the employee database, will also be discarded. So I'll say inner join is safe to go with. Anyway, so what I'll do is that I'll actually import the pandas library as PD, and we're gonna say meshed because that's the first step, right? We just want to make sure that we match the employee survey, then take the Facebook employees table, then I'm just gonna merge it with Facebook hack survey. Then I'm gonna say the left on. So this is not a left join, it's just saying the left on column. It's gonna be an ID. Then the right on column, right? These are like the columns that I'm joining on, right? Think of it that way. So we're gonna be an employee. I think it's called employee ID. Then we have, we're gonna do an inner join. If you're on an interview, you can ask the interviewer if like they care about the employees that left and they're no longer on the employee table or something like that. Because what inner join will do is that it will just prioritize ID match. If an ID is on the both tables, it's gonna retrieve those, right? So it's quite important to note that. So what we're gonna do now is that since we have this table, we have joined the two, because we are told that we need an average, right? They say that show average popularity of this by location. So I think it makes sense for us to say let's group by location, right? Because we want to know for each location. I'm just going to preserve all my columns by saying index equals to false. For each column, for each location, I just want the average of the popularity. So assuming that the popularity column is a float, so it's going to be popularity. Then we're told that output the location along with the average. So we're just going to say we only want location and we only want popularity. I'm gonna run this code. Did I get an error? Okay, I did not. And we solved the problem. Okay, it wasn't that hard. I'm just gonna show you an SQL script for this code. So this is how you actually do it in SQL. So what you'll do is that you'll select the location and just use this average function on the popularity column, and you'll just do the join just like we did, but it should be an inner joining on the employee and grouping by the location. So it wasn't, I feel like this one was quite straightforward. They wrote this paragraph which could have made it a lot of complex, but it was just a statement. But yeah, let's go to the next question, guys. Hey guys, yeah, this is the next question. So I feel like this one is also hard from Amazon, and looking at this question, I think it's pretty much the same with the one that we did on question 2. So it says that we need to write a query to return territory and corresponding sales growth. Compare growth between quarter 4 and quarter 3 of 2021. That's quite important. So if territory, say TT21 has sales worth 110 in Q3 and sales with 110 in Q4, then the sales growth will be 10%. Okay. Output the ID of the territory and sales growth. Only output the territory that had sales. It's a hard question, but I think reading at this is quite doable. So if you watch the second video that we just spoke about, what we need to do is that we need to start like solve this like like as a sub problem, like small chunks. That's what we do. So for example, we take the data set, we can filter by, we can see that they say that they want 2021, right? That could be our first step. It's like, okay, we're gonna filter by 2021, but do we have a year column, right? So we have a customer sales and we have a customer territory. So we can see that we definitely have a date. So we need to join these by the territory, okay? Because that's what the question wants us to do. They want the sales growth by big territory. Anyway, so yeah, so that's what we're gonna do is that we're gonna make sure that we filter by 2021. Then what we do is that we get that and we try to get a quarter in that 2021. We try to get a quarter like 4, quarter 3, quarter 2, quarter 1. But like I said, with the second question was that these, when you get a quarter, they're gonna be vertical. So it's gonna be hard to compare because here you need to compare quarter 4 and quarter 3. So what you do is that you use that technique whereby you're gonna create two separate tables, one for quarter 3 and one for quarter 4. So this way you can actually be able to compare them horizontally. Okay. Then yeah, you're gonna group by territory and you're gonna sum up. The rest, I think it's as much as I'll be explaining this as I'm writing this, and you'll see. So without wasting any time, guys, let's get into it. Okay. Don't worry if you don't understand like completely. I'll show you everything and I'll explain in more details. Okay. SPD. So the first thing that I would like to do is that I would like to join these two columns and I would like to join inner join. The reason I would like to join inner join is because I want to make sure that customer have like a territory. So I think doing an inner join is a safer join and it makes sense in this case. So we just gonna say we're gonna call this joined cast sales. Okay, we're gonna say FST. Let me just copy this just to avoid silly mistakes. So we're just gonna say dot match. I'm matching this with the map dot customer. I think it's called customer territory table. Then I'm just gonna match this on customer ID. Okay, we're gonna make sure that this is joined in this is an inner join. Before we continue, to avoid silly bugs, let's just look at how our table looks like. So this is what it looks like and this is what we expect. We have customer ID and we see the territory that they're within and we can see their order and order value and date. Like I said, all the time, the second advice that I'd like to give you guys is that do all the simple stuff first. Like for example, you can see the date here. Maybe there is 2020, 2019. You care about 2021. So why not start by that, right? So we're gonna write here full time on 2021 sales. Right? So we're gonna say joined, which is joined, and I'm gonna paste this. See, this is supposed to be like that because we're filtering, and I'm just gonna take an order date. Then Actually, I think I like this tutorial because it teaches, it kind of like teaches us on the how to work with date. For example, to filter on a date on the year, you use this function dt.year, and you're just going to say equals to 2021. And if you run this, you should only get 2021 results. And now we can actually call this cast cells 2021, right? We can say equals to this. Okay, so what do we do then? I like to get the quarters, right? That's the first thing that we want to do, because we're told that we need to compare the growth between quarter 4 of 2021 and quarter 3 of 2022. Of 2021, I meant to say quarter 3 and quarter 4. So what you want to do is that you want to take this table that you just computed now, and you want to create a column. You're going to call this column, I'm going to call it quarter, and this you're going to say equals to, you give it this table, and you take an order date, okay, and you do the same function, which is dt, you call the same date time function, then you say to period equals to q. So this will do the trick of converting that date to quarters. And for instance, if I run this, you just paste and you run this, you'll see a new column called quarter, and it is those quarters. As you can see, it's quarter 2, quarter 4, and this is nice to work with. Okay, so now because we have that, what we want to do is that you can see that we can compare them. You see what I was telling you about. I was telling you about that these are horizontal. It's hard for you to compare them. So you know what we're gonna do, right? Yes, we're gonna create two tables. For us. Two tables for Q3 and Q4. So, and we're gonna join them. So now we're gonna say cells, right? Q3 equals to take this, okay, and then you just gonna have to filter. We have a quarter, okay. Then you just wanna say equals to what is it? 2021 Q3. Okay, then you're just gonna have to copy this guy. What you wanna do is that you wanna do the same thing, but now you're gonna say for cells 4. You can think of quarter 4, and here you're just gonna filter by quarter 4. And if you run this, you see you have quarter 4 results. This is good, right? So now we want to join these two. So how can we join these two now? So the good thing is that we can use, I think, inner joins will work, so that we can preserve the important aspects of these two tables. So we want to output territories that had any cells in both quarters, right? So that's why I'm saying inner join should work. So so I think we're gonna say territory cells, I don't know if I'm pronouncing this correct. But, so we're gonna say cells Q3, and we're gonna say dot match with cells 4, right? And we wanna match this on territory ID, because that's what we care about. Then how we want to do an inner join, because we want to make sure that we have territory for both cells quarters have territory, right? So I'm just gonna run this and make sure that we have everything. Territory ID is not defined, and I think this is because this is supposed to be a string. Yep, and it works. So this is what, guys, I'm looking for. This is good news because now they are on the same row, right? We can compare these. We can write the equation. We're given this formula here. We can write this easily without any pain. So because we just look at the previous quarter 3 and quarter 4 and we just compare and we just see what was the sales growth. So without wasting any time, let's do that. So what we're gonna do now that we've joined this, we're gonna say territory sales. We're gonna use this function dot assign. Then we're gonna take sales growth, which is something that we're gonna define here. And I'm just gonna say equals to lambda. Take x. We take 100 multiplied by, I think I was saying that x, we take x because we want the order. So I'm just gonna say order ID. So I'm using this formula here, guys, here. So we take order y, not order date, order value. Okay, so just gonna say order value. What do they say? They say that we should subtract. I'm just gonna say x. Then I'm just gonna use x here. Then we divide. Right. Let's see. I just want to make sure that I'm not making any silly mistake. I think short divide here. X. Then I'm just gonna say divide by the x previous. So I think this is a growth formula, right? That's what it is. So it's nothing complex. So, but you can think of like we essentially like create a new column, right? And we say on that column, then we create this lambda function to say take this column, right, which is order value y. You can think of it as like quarter 4, and take quarter 3 and divide by quarter 3, like just like we are told here, right? So that's what we're doing essentially, and we take in the present, right, and we subtract the previous and we divide by the previous. I think this is a formula for growth. So after we are done with that, we can just like say territory sales. We created a new column, which is the growth column. So we just need to return that column. So we are told that output the territory that had the cell, any cells in both quarters, right? So that's why here we had to do an inner join, because if we didn't do an inner join, it's just gonna make sure that we had cells in both sides. So I'm just gonna output this and make sure that I give them their territory ID and we had sales growth. Check solution. It worked. I validated this against their solutions. I don't have a previous, but I did validate it, and yeah, this is how it works. So, but anyway, this is my solution, guys. Yeah, I hope you enjoyed it, but the key takeaways here was that we reused the same method that we did, and most importantly is that one thing that I'm realized that like unlike software engineering questions, software engineering, like you require to know like binary search, binary trees, DFS, all of these techniques and these algorithms and data structures. But with SQL, one thing that I'm realizing is that you just need to be good at understanding the question and you break it down, then you just solve the small pieces and you work your way towards the end goal. So that's one thing that I like about SQL problems. And yeah, I think this was quite an interesting problem. That will be my ticket two key takeaways. And also my another key takeaway is that learn about these date functions. They're quite useful. For example, here to get a quarter, we're able to get it with like one line of code, and to do it like manually could have been a tedious task. So it's nice to know about these functions that they exist. So yeah, and you can use lambda functions to like transform the values with one line also. That's also another key takeaway. So anyway, let's go to the next question without wasting any time. So looking at the next question, guys, this one is also by Airbnb. It states that we need to find matching host and guest in a way that they are both of the same gender and nationality. So I think they say that output the host ID and guest ID of a matched pair. So essentially what they're saying is that we are given two tables, and what we need to do is that we need to match the host against the guest, and we need to match them on their nationality and gender. So where nationality and gender is the same, that's a match. So to show you from a visualization perspective, I'm just gonna open up OneNote. So what's going on is that we have two tables, right? And we have another table for the guest, right? So you can think of this as guest, and we have this table as host. So this table essentially has a nationality. Maybe it could be SA, gender, it could be male, maybe USA, maybe female, could be USA, male, right? USA, female. And similarly on the guest, we have USA, female, USA, female, USA, male, SA, male. So what they're saying is that for USA male, you have to match it for the host, which is from coming from a USA and is a male. You have to match it with the guest, which is USA male. So you have to match it with this one. Okay. For female, which is from USA, right? And if she's a female, you have to match it with these two guests. Okay. So essentially, there's a method in SQL that is called cross join. So you can think of cross join. Essentially, it's going to allow us to handle this scenario here. So it's going to make sure that it essentially what it does is that it creates multiple. It's more like it's not necessarily duplicating, but it will try to, for each record like USA female, it will try to match it with USA female, and it will create USA female to match it with these. So it will try to create two records, right? So you can think of it as like SA female, SA male, it's going to try to match it with all the SA males, just like that. But the problem with cross join, the problem with using this type of join is that it's too expensive. So I doubt the interviewer might actually accept this solution, because actually cross join is way too expensive. You can think of it as it duplicates. So each record is going to have to face this. So you don't want something like that. How can we then solve it? So let's go to the code and start drafting the solution. So I am thinking that one way we can go about this is that we can try to actually join these two tables, right, based on nationality and gender. So if it happens that we have multiple nationality and gender with the same nationality and gender, it's fine. It will try to replicate it multiple times. That's okay. We're gonna do an inner join to make sure that whatever it's inside here, we also get it inside here. Okay, so I know that I might actually be complicating this, but I will actually like to code it up, then it will actually make sense as we go through. Okay, so as I said, we're gonna use pandas, which you're gonna say A, B, and B. We're gonna say host dot match. We're gonna match with a P and B guest. Then we're gonna say left on equals to nationality, right? And we're gonna say gender. Then we're gonna make sure that right on equals to these two. I think you can use on, I'm not sure, but anyway, let's try it this way first. But I think you can just use on, especially if the column are the same. But we will see. Let's try this one first. So I'm gonna join them by inner, because remember that the column says we want matching. So if you do something like full join, you're not gonna get that. So inner join is just gonna make sure that whatever is on the host table, right? Actually, I made a mistake here. It's also on the Airbnb guest table. So it's just gonna make sure that I'm getting all the things that are inside and are in both tables. Okay. But it's possible that we're gonna get a lot of duplicates. So we need to handle that. So we are told that we need host ID and guest ID. So I'm just gonna say, okay, get your host ID. There we are. Get your guest ID. There we are. Right. If I run this, it's probably gonna fail because we have duplicates. Did I make any mistake? Let's see. Okay, I think I did. I think it's not called host. Okay, cool. So these are the results, and these are all the matching guys. But as you can see, we have a lot of duplicates, 0909. That is because of we did that inner join. If you watched the first, I think it was the SQL tutorial that we did previously, I spoke about, let's go to whiteboard. I spoke about this problem whereby I did mention that if it happens that you join in your tables and you have like USA male, and also this side you have USA male, right? It will create two records even if there's only one thing this side. It will create two. This side is also going to be USA. So you'll be having duplicates. So usually what people do is that they group by. So within this case, we don't have to. They group by to avoid duplicates. In this case, we can just say dot drop duplicates on the two columns. Okay, if I run this, it's just gonna give me all the unique guys, and you see unique. But the point here, guys, is that all of these IDs are the IDs that are matched, meaning that these people are from the same country, they are the same gender. Okay, so I'm just gonna submit here, and it's solved. Okay, so now I spoke about cross join, which I said it was bad, right? But how would you then write it? So I'm just gonna copy this, paste it here. So this is how you'll do it as SQL. So this is very, very inefficient. So your interviewer will probably want you to write an SQL that is probably like this. So this is not that bad. So given that Airbnb probably has like billions of records, and using something like cross join is just gonna, yeah, it's just gonna not work out well. So I usually use cross join, especially if I'm working with like less data. Then I can actually use that. There are some cases I think cross join is quite a useful solution at some point, but in this case I think we were able to figure it out. So that'll do it, guys. Yeah, let's go to the next tutorial. So now, guys, we're looking at top call votes, right? And you might be asking yourself, why did I choose this Yelp question? It's because of I like these edge cases, and I like these questions whereby there's a lot of edge cases. Also, it's one of those questions that I think I have some sort of like available advice for you. But anyway, let's get into it, and we're gonna see how it works. So they say that we need to find our review text that received the highest number of cool votes, right? Output the business name along with the review text with the highest number of cool votes. Okay, this seems like a straightforward question. So we have this data set, and essentially we have this call. It's an integer, so I'm assuming that this essentially it refers to let's see, I just gonna I'm gonna because I want to see if like calls, does it refers to the number of call votes, or it is an 0 to 1 column. So I just want to know. So see one here, yeah, you see. So I think it's number of votes, these two. Okay, so what are they saying? They're saying that we have this. Now that we saw the schema, let's review the question again. So they say that find the review text that received the highest number of cool votes. Okay, so yeah, some of you might be thinking, why not just like sort this, because of we don't have to do any group by. We know that the cool votes is the number of votes. We don't have to group by anything. And they are telling us that they want like a specific review, so it's not like the reviews are duplicated or something like that. So my thinking process is that we can sort this table in like descending order, then we can get top one, right? So what I'm saying here is that we can get this table and we can say sort values, and we can say by equals to call, right? Then we can say descending. I'm gonna say ascending. I always get the spelling wrong. I'm gonna write here false. Okay. Yeah, like then we get, they say that they want the top, so we're just gonna say head 1. Then what I'll do is that I'm just gonna select the business. Let's do this. Just for ease of readability, and because I want to select multiple columns, I'm using double array. We call them list in Python. So I'm just gonna review text, and you guessed it, I'm just gonna select call. So now, will this work? So the edge case that I was talking to you about is that we're selecting the first one, right? But what if like the top have equal number of like coolness, like equal number? Let's say like the top cool is equals to 10. So how we did it is that it's still correct, like, but it's not correct like in a way that the answer will be acceptable. It's still valid in a way. It's just that we did not cater for a scenario whereby we have multiple these things are equal. For instance, if I run this code, I don't know what I did wrong. Let's see, did I make any mistake? So let's say, for instance, we have this, we selected top one, and this is the top coolest review, right? But what if there is another one with 10, and we selected only the first one? because this here they say that output the business saying along with the so receive the highest number of coolness, find the tester that receive the highest number of coolness. So you can probably ask your interviewer if like about this edge case, right? That if like we have like equal reviews that receive the same number of like coolness, what do? Do you output both of them or something like that? But the point that I wanted to raise was that just ignore such things as just head, limit, just ignore them. Do these stuff dynamically. So I'm just gonna copy this code here and I'm gonna actually, you know what, I'm just gonna write it from scratch because I realized that it takes me. But the point is just ignore such things because sometimes you're gonna get like, for the most part, for the problems that I've solved, I've realized that actually if you do something like this, like on SQL, like limit head one or something, you're always gonna be off because usually like even when you do this from a ranking perspective, there's always gonna be, not always, but for the most part, there's like equal and you might want to retrieve all of them. So anyway, I'm gonna get the Yelp review. I'm just gonna say, so what we're doing now is that we're filtering by, we just want the call that the max, like, you know, the max guys. I'm gonna say actually Yelp review. So I'm just gonna say call and dot max. So what I'm doing is that I'm saying get me the max, like, you know, the max, we know that it's 10, so I want anything that matches the max. Then what I'll do then is that, yeah, then I'll just copy this to save some time and we're gonna submit, run this code, and yeah, now we are able to get all the highest guys, and if we submit this, it works. So it's the same thing. So yeah, so I'll say the key takeaway is that be careful, especially if you start hard coding like things like this, unless if they wrote explicitly that they want top one and like they only want record, then I think it'll be safe. But for the most part, I'll say doing things dynamically, or ask your interviewer, and if you're in an interview or maybe if you're at work, yeah, you can access your use case. So anyway, let's go to the next question. Now we're gonna look at this question, which is find top 10 ranked songs in 2010. So I chose this question because the previous question stated that find the top, but they did not actually mention the number. I think they said top, something like that. So in this case, they specifically tell you that they want the top 10, right? So it's fine for you to include a limit in this case, right? Because they just want top 10. If in case it happens that there are some songs that share the same rank, right? So it's fine. You can just include top 10 exactly. So anyway, without wasting any time, the question states that what were the top 10 ranked songs in 2010? Output the rank and group name, song name, but do not show the same song twice. Okay. Sort the results based on the year, rank in ascending order. Okay. So I think this also looks quite straightforward. We only have one schema. We have a year, and good thing is that we don't actually have to apply a ranking function. They gave us a year rank. We have a group name, artist, song name, ID. Okay, so one thing that I like to do is that I like to, especially given information like this, what you want to do is that you want to start with small detail, or you can end with them. But in this case, I feel like the first detail, which is that we need to filter by only songs in 2010, that's the first thing that we could do. Then after we've done that, we can then sort by their year rank, because they say that what were the top 10 ranked songs. We can sort by the year rank, because that is going to actually help us to know the top songs, right? Then we output the rank, group name, and song name, right? However, you must be careful because they also tell you that do not show the same song twice. So what this means is that after you have like sorted this in descending order and you have gotten these columns, you can actually remove duplicates. And then after you've removed duplicates, then you can now get the top 10. Okay, so if that confuses you, it's okay. I'm just gonna explain it in more detail as we go along. So we're gonna get the table. Then what I'm gonna do is that I'm gonna take the table. I'm just doing the easy stuff first because we know that we don't care about the other year, we care about 2010. So that's what I'm doing. It's an easy thing to start with. So I'm just gonna say 2010, 2010. Then I'm just gonna say sort the items, sort values, so we don't have to do any ranking functions. We're already told that we can actually sort the values by the year rank. So this is what I'm gonna do. And then what I'm gonna do is that I've sorted these. So my assumption is that the rank, it goes like from one means like the best, like the top. That's my assumptions here. So that's why I don't I think the default is ascending. So that's why I don't do like ascending equals to false. Okay, so just keep that in mind. Yeah, then we're told that they want the song name. So I'm just gonna give them the song name. I'm just gonna give them the group name. I'm gonna give them the year rank. So this is where the tricky part is. I know this is an easy question, but it can be tricky at some point. So the tricky part is that instead of getting the top 10 right away, like doing something like head 10, these top 10 could be having duplicate, right? So what you want to do first is instead you want to remove the duplicates. Like you want to say drop duplicates, right? And I want to be honest with you, the reason I don't actually run this stuff and show you the table is because in an interview you are actually supposed to write this on a Word document or maybe something like that, and you won't even see the tables how they look like. So you must train your mind to visualize the table as you write your code. So that's an important skill. So that's why I won't do something like after I run this, maybe let's show you example, maybe to say, okay, run this, what did we do? Please don't tell me it's this. Okay, let me do this. So let me just continue. Anyway, it's fine. But the point was that we were gonna see that okay, there were duplicates. So I'm just gonna return the code that we wrote, which is drop the duplicates and we get the top 10. So here I just want to leave the comment and say that so we drop the duplicates before we select the top 10. Why are we doing this? It's because if we select the top 10 first, we're going to select also the duplicates, so the result is not going to be accurate. Something just to keep in mind. I think this has to come close here. I'm not sure. It says line 5, sort values by this. You know what? This thing gives me a horrible experience all the time. Let me just do this. Will this work? No, it doesn't. Let's do this. Okay, let's just do this, guys. That's the thing about this, because it does not indent well. But anyway, they say that in an interview you are required to code on a Word document, so it's fine. So what I'm gonna do is that I'm gonna break this code into pieces because I just don't know what's going on at this point. So just gonna remove this, see if we making any progress. We are. So I'm gonna include this code. So this backslash essentially that allows us to include more lines. So below that, so it's a nice trick in case like you don't want to do everything on one line. So it tells Python that okay, there's a code below this. Okay, let's see what's now. Okay, it's because of no, that's fine. I'm just gonna remove this part here. I just don't know what the problem is. I don't know if it's because of indentation or what is it. I just have no idea. And I think the problem might be here. It's because of space, maybe. It's because of this part. I'm just gonna remove this code. Just gonna select head 10. So it works. I think it might be it refuses to use this, but yeah, it worked. Maybe I don't know. Maybe that might be the case. I just don't know why. But anyway, this is the solution. We don't have duplicates and we have top 10 songs. Then I'm just gonna submit this, and it worked. Apologies guys about those errors that I was having. I think yeah, it's how it is, right? Anyway, thanks guys. I think we are done. We're able to solve all the 7 questions. Yeah, I'll see you guys in the next one. Thanks. Cheers.